Hello, it's Dumplet here. Welcome to a collaboration project between Dumplet and Cedie's Mathverse on Hong Kong International Math Olympiad questions. For this one, find the number of lattice points on the circle with radius 40 centered at the origin. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now, lattice points, if you don't know, they're just points where the x and the y coordinates are both integers. So for example, like 1, 2, since 1 and 2 are both integers, negative 3, 5, because negative 3 and 5, they're both integers. So that's pretty much what lattice points are. Now, let's try to disregard about the lattice points first, but to represent this circle, because it's a radius of 40 and centered at origin, so we can use the center radius form for that. The center is at 0, 0 as per the given. The radius is 40 as per the given. We simply substitute it into the center radius form. We have x minus 0 quantity squared plus y minus 0 quantity squared equals 40 squared. And that's just simple. We just make it into x squared plus y squared equals 40 squared. And this is where the part that x and y are integers will come in. Now, generally, when we see this, the first thing that comes into, at least in my mind, is the Pythagorean Theorem, because, well, it kind of looks like it. A squared plus b squared equals c squared. So immediately I would think of maybe Pythagorean triples. Now, here's a trick on these types of questions. Now, when we talk about Pythagorean triples, we can try to get like the ratio of those three sides. So for example, we know that 3, 4, 5, and 6, 8, 10, those are two famous Pythagorean triples, but essentially they only mean the same thing because they both have the same ratio. 3 is to 4 is to 5. Now here is something interesting about all the ratios. Dumplet here is going to tell you that the largest side, or also known as the hypotenuse of the right triangle, it's going to be always corresponding to an odd number. So for example, in this case, 40. Well, in this case, it's going to be the hypotenuse because a squared plus b squared equals c squared. So 40 here acts like the c. So 40 should correspond to an odd number. Now, let's take a look at the factors of 40. Well, 40 in prime factorization is 2 cubed times 5. Now, we want 40 to correspond to an odd number. So 40 corresponds to an odd number, which should be a factor of 40. So it's either 40 will either correspond to 1 or 5. Now, obviously, 1 is impossible. There is no Pythagorean triple with 1 as the hypotenuse. So the only possible correspondence between 40 and the part that we want as a ratio is the 5. So, which means 40 should be part of a Pythagorean triple in the ratio 3 is to 4 is to 5. Now, from this, there's only one Pythagorean triple that corresponds to that, because if 40 will correspond to the 5 in the Pythagorean triple, then it must be 24, 32, and 40, nothing else. And this will tell us the integer solutions actually, because if you go back here, well, we know that x can be like 24, that's one solution, y can be 32, that's one solution, but then again, we're talking about integers here, so we have, well, positive negative 24s, positive negative 32s, so we should be able to have these four solutions. So these are points on the circle, and yeah, again, lattice points because they have integer coordinates. Now, we have 4 here, but don't forget, we can easily switch those two values. So for example, we could have 32, 24, just simply switching those two values. So simply switching the 24 and the 32, and we can do the same for the rest. So in total here, we have 8 possible cases. So we're done with this part. Now, you might immediately think that, okay, 8 should be the answer then, since there's only one Pythagorean triple, technically, that we can assign to this sort of Pythagorean theorem. But there's one thing that we're missing, and it's kind of the obvious ones that we tend to miss. But, well, we can easily let one of those two be 0. Oh, sorry, a correction here, this should be 40 squared. But we missed the case that it can simply be, 1 can be 0. So for example, well, x can be 0 over here, and then y is going to be my 40. Well, it works. Well, it's just not covered in the Pythagorean theorem case that we did a while ago, since we didn't talk about numbers being able to numbers being 0. So that's something to look out for. So this is kind of a trap in these types of questions. But anyways, we have 0, 40 and 0, negative 40 if x equals 0. But then again, we have the opportunity to switch them. So not 2, but here we have a total of 4 solutions. So we have 8 from the first case, 4 from the second case, and we're safe to conclude that there are no other possible cases. But then again, the 4 case here is the more dangerous case that you don't want to miss. So anyways, taking the sum of the possible lattice points in both cases, we're going to end up with 12 possible lattice points as an answer to our problem. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!